In your journey of machine learning, data science, or AI, you might have gone through multiple research papers on classification, on regression, time series analysis, on blah blah blah, multiple topics. You know what? The most important and crucial thing going through a research paper is patience. Many people lose patience while going through the research papers in depth because research papers usually have equations, complex wordings, which is kind of difficult for people to understand. Not everyone can easily understand from the research papers. Can we leverage the generative AI concept or the large language model concept to create a portfolio project which can actually make my task easier? I'm thinking like a chatbot which can take my research paper as an input and I can ask something in plain English or easy terms that what this research paper is all about, what are the main components of this research paper, and the bot should be able to respond me with a layman's term. Is it possible? It is 100% possible, and in this video we are going to talk about this amazing portfolio project based out of large language models and RAGs concept, and we are going to take it ahead and build a chatbot using a custom data set which is a research paper, and our final chatbot should be able to answer my questions in a very easy and effective way. This portfolio project is part of my data science and AI masters program. Those who don't know about this program, this is a program of 140 hours with 30 plus portfolio projects containing all the modules that you can ever imagine in the field of data science and AI. We have Python, SQL, Excel, statistics, EDA, machine learning, NLP, transformers, deep learning, computer vision, generative AI, and a lot more things. In case you are fascinated to learn data science and AI, please let me know in the comment section or reach out to me personally and I will be able to onboard you. The course program fees is not much. It was initially priced at 9,999, but if you are watching this video, I have an offer till 31st of August and the offer is going to be 5,999. In case you're interested, let me know and let's get into the video and enjoy this amazing generative AI portfolio project. Hi, welcome to this practical session on RAGs. So in this particular video, we are going to focus on a particular use case of using a custom data, and then based on the custom data, we will be calling OpenAI APIs. So before getting into the custom data, I would also like to show you this part. What is this part? This part is very simple, where you are passing your entire input, your prompt, and then based on your prompt, you are calling a OpenAI ChatGPT model, could be GPT 3.5 or GPT 4, and then you are getting a response. Exactly the same fashion how you interact with ChatGPT or POE or u.com. Right? Let's say you're asking what is EDA. Now this basically goes as an input and we are calling the GPT 3.5 turbo model, and the turbo model is responding us this way, right? So let's try to get into that. Now before getting into that, there are few things to note. We will be installing few libraries. First of all, we will be installing OpenAI, then we will be installing langchain, then we will be installing langchain community, and then we will be installing FICE CPU. Now I'll explain each of them, so do not worry about it. And on top of that, let me use a code for this. On top of that, I will also be sending you the requirements.txt so that you can pip install the requirements.txt directly so that all the models will be installed. Installing libraries. So let's start one by one. We'll first get started with pip install OpenAI. In my case, it says requirement already satisfied because I have already installed it. In your case, it will be installing it from scratch, right? So you can run these 4 pip installs one by one. I'm not running it because in my case it's already installed. The next thing is importing libraries. Okay, so first of all, we will be importing OpenAI. Then from langchain document loaders, we will import PyPDF loader. Each and every method, each and every library, each and every function will be explained, so do not worry about it. From langchain.embeddings.openai, import OpenAI embeddings. Okay, and then from langchain.textSplitter, import recursive character text splitter. Okay, we'll be importing all of them. So everything is successful because all our modules are already installed. Now the next thing is, as we will be calling OpenAI model, remember this thing. In this case, we are going to call the OpenAI model, right? OpenAI model is nothing but your ChatGPT, right? OpenAI has already provided APIs. You can directly call them and talk to the LLM. But in order to access this API as a user, when you are accessing OpenAI's API, you need a key because it's not directly accessible. You need a key. Now, how to create a OpenAI key? Well, unfortunately, I cannot show you because I'll have to again log into my VPN and then go to OpenAI website and create a key. Because in Hong Kong, OpenAI is not accessible. So I will leave that up to you because there are tons of videos on YouTube, on various other platforms where you can leverage those videos to create a OpenAI public key, right? Nowadays, OpenAI has made it very strict. Initial $5 you will get it for free, but beyond that, if you want to do some more tests, you will have to recharge your OpenAI bucket maybe with $5 or $10 and then try it out. Do not, while you are testing all these things, when because you are in your initial phase of your journey, my recommendation will be stick to 3.5 turbo, because if you do GPT-4, the cost will be high because GPT-4 is at least 100 times more costlier than GPT 3.5. GPT 3.5 is around $0.01 for 1 million input tokens. However, GPT 4 is around 37.5 rupees, around $0.4. And again, GPT 4o, I'm not sure, it would be even more expensive than that. So in my case, I'm using my OpenAI keys. So I'm setting up a parameter. Now I'm going to use my key, but by the time you will receive this video, this key will not be available to you because this is a private key that I'm using and I don't want to make it publicly available because unnecessarily my key will be used by many people and I'll have to pay that. So create your own key. Okay, so I'm creating my own key. Going forward, I'm just hiding that code because I don't want to show the key to a lot of people. Next thing is, I'm directly calling the from langchain.llms import OpenAI. That's it. Okay, done. And then I will be calling LLM is equals to OpenAI. And here I will be passing OpenAI API key is equals to, I will be passing my original variable OpenAI key. That's it. Now what's happening is you have initiated your OpenAI large language model. Now you have to just ask a question the way you ask to ChatGPT. What is EDA? Now let's say we will be asking this thing. What is EDA? Explain EDA in just 2 lines. This is the question I'm asking. Simple. And I'm getting an answer. Now here we'll be doing the same thing. I'll be calling llm.invoke and I will ask this question. Let's see what the answer is. and we'll try to compare the answer. Okay, so that's great. Let me try out with another API key. So I have created another API key. I will unfortunately not be able to show that OpenAI key because that's an active OpenAI key that I'm using for all my proof of concepts. Let me run this, and here you will get an output. Exploratory data analysis is the process of blah blah blah. Let's try to compare this output. Okay, let me just break down it into few lines. Let's say like this, and data visualization like this. I'll go to my POE and I'll try to get this answer as well, and we'll try to compare the outputs. See, it will not be a replica, but eventually it will be a very similar answer in both the cases. So in the first case, in my Python code, it is responding. ED is the process of examining and visualizing data to gain insights and understand the underlying patterns and relationships. It involves statistical methods and data visualization. And in this case, it is telling you it is the process of examining and visualizing data. You can see it's almost correct till here, to gain insights, but here to uncover patterns and detect anomalies and gain insights. Okay, so it is more detailed in data understanding and decision making before advanced. So see, the whole idea is almost the answers are same, but the wordings are different. It is exactly like the same thing. Let me try to explain you in this way. Let me go down and explain. So first of all, I'm calling through POE, right? POE is nothing but your OpenAI APIs, right? Now here, when the user is asking, I'm basically getting an answer, right? Obviously, when a user is asking, we are asking through a particular session, right? When you are asking the same question in your Python notebook, eventually you are also using OpenAI APIs, but you are using a different session. What's happening is, here also the question is same, here also the question is same, right? Here the embeddings and here the embeddings will be same. The retrieval mechanism is also same, but the chat completion is different. Because here, imagine this is person A. Person A is answering like this, and person B is answering like this. Because chat completion is completely random. The context is same. It is also explaining you EDA, this is also explaining you EDA, but the way of writing the answers is different. But the matching mechanism will be almost same, right? So I hope you're able to get my point, right? So this is the basic thing. Now we are done with the basic things. Now what we will be doing is, we will be onboarding the PDF document. So we will be converting the document into some sub documents, and then we will be doing the embeddings, and all the embeddings will be calling to the model. Similarly, when the user is asking a question, again you are doing embedding again. So basically here, if you try to do this way, what's going to happen is, embeddings and embeddings, you get the most relevant passages, and then you call the model for chat completion, and then you get the output. So we will be following this architecture right now, right? So let me write it down here. So here, using custom data set, let me just bold it out. Done. Let me write down the code and then I will explain you the code. Okay, so here what we are going to do is, we will be using a rag paper. I'm going to use this particular rag paper as an input, and this is loaded, so I'm copying the path. So PDF reader is equals to PDF loader, and here I will pass the path. That's it. Okay. Okay, let me write it down. Give me some time. I'll write it down and then I will explain you the code. So documents equals to PDF reader dot load. My bad. And then after the documents, we need a text splitter. Text splitter is equals to recursive character text splitter, and here I will be defining my chunk size. Chunk size, by default there is no chunk size. Text splitter. Anyways, let's say I'll pass some chunk size, let's say 1000 chunks, and then chunk overlap 200. That's it. And then chunks equals to text splitter dot split documents. Okay, let me run this code. It's not working. PyPDF package is not found. PyPDF package is not found. PyPDF loader is using PyPDF loader. That's weird. PyPDF is already loaded from langchain, so it should work. PyPDF package not found. Please install PyPDF. That's weird because in my case it should have been already installed. Anyways, if it's not installed, maybe we'll write it down in the requirements.txt. So I'll install this PyPDF. I have already installed langchain. Internally langchain is using PyPDF, so it should logically also import also install this, but it's not. Anyways, I'll jump back to the code. I'll run this. It should work fine, and yes, it is working fine. Now let's try to understand this piece of code. What's happening? It's very simple to understand, right? We have taken a PDF document, right? And then we are doing the loading here. What exactly is recursive character text splitter? So if you go back to this architecture, this is the part. Okay, so recursive character text splitter, maybe also I'll write it down here. Recursive character text splitter is a text splitter that splits the text into chunks, trying to keep paragraphs together and avoid losing context over pages. That is what recursive character text splitter is doing. Okay, basically the resulting chunks of text are stored in variable chunks. After your text splitter is done, you are storing all your resulting chunks in chunks. That's it. Now moving forward, from langchain.vector_stores import FAISS. What is FAISS? FAISS is nothing but it's basically by Meta. Meta has provided this very good library. It is a library used for efficient similarity search and clustering of dense vectors. So let us import that. from langchain dot embeddings import. We have already imported OpenAI embeddings. No, we have not. Okay, and then after that, so let's say create embeddings. Embeddings is equals to, I'll directly call this OpenAI embeddings. API key is equals to, I will pass my OpenAI API key. Done. And then DB is equals to FISS from documents. Documents equals to chunks. And embedding equals to embeddings. Yeah. Could not import tick token. Anyways, we will also be installing tick token. I'll write it down here. Okay, tick token should be installed, and then let me run this piece of code and then I will explain you what's happening. So till now everything is clear, right? We have taken the PDF document into chunks, right? Now chunks needs to be created embeddings. So here I'm basically calling the OpenAI embeddings using this OpenAI embeddings, and it is obviously present inside the langchain library, right? It uses the OpenAI API keys because using that you are creating the embeddings, right? So OpenAI embedding class basically is responsible for generating the embeddings for the provided textual data using the OpenAI GPT models. After creating the embeddings, you can see we are creating the vector store. Here I am passing my documents, I am passing my embeddings, okay, and then I'm creating the vector store. Now, what is FAISS? I already talked about. FAISS is basically used to create and manage vector stores based on the FAISS. FAISS simply means Facebook AI similarity search. Yeah, it's a powerful library for similarity search and clustering of dense vectors. See, right now we are using FAISS. Going forward, after this particular session, we will also be creating some Pinecone vector store, and I will show you how the vectors are getting stored on Pinecone. Right now, I cannot show you, but when we use Pinecone, we will be able to show you the vectors. So you will be able to have a better feeling. Oh, this is how it is working, right? Now let's try to move ahead from langchain chains. We'll be creating some chain, conversational retrieval chain, and then from langchain prompts import prompt template. So condense. Let me write it down and then I will explain you in one go. Condense import prompt equals to prompt template. From template, given the following conversation and a follow-up question, rephrase the follow-up question to be a standalone question. Chat history, and then I will write it down as chat history. Follow up input question. Standalone questions. Okay, should be good, and then I will create QA is equals to conversational chain from LLM, conversational retrieval chain LLM, right? LLM is LLM. LLM equals to LLM. Retriever is equals to db dot as retriever condense question prompt is equals to condense question prompt, and then return source documents equals to true. Okay, okay, successful. Now let's try to understand this piece of code. Okay, so what we are doing here, we have imported two things, right? We have used conversational retrieval chain and we have used prompt template. Now, first of all, what is this conversational retrieval chain? When we are calling conversational retrieval chain from LLM, basically this method initializes the chain with the specified parameters, right? The LLM parameters is nothing but your OpenAI LLM, right? The retriever parameter is nothing but it is the retriever being used for retrieving the relevant information from the document. What is DB? DB is nothing but your embeddings, right? If you go here, your embeddings. So let's say this is your DB. Let's say this is your FAISS DB, right? So this is nothing but your DB as retriever, and then this is the template that we have passed. What is this? This basically specifies the prompt template to be used for condensing the follow-up questions into standalone questions, because you will be asking not just one question, right? Let's say what is 2 plus 2? What if we add 5 to it? Now you can understand this thing. This is the first question that I have asked, right? You, when you're asking the next question, the previous question also needs to be taken care of, right? So accordingly you have to give your prompt, or else your prompt could be also this way. Let's say your prompt could be, let's say you want to create just a Q&A chatbot. You don't want to create a chatbot to keep asking questions from the previous context. Each and every question will be completely different, but you want your chatbot to behave like someone, so you can also do that way. Behave as a AI expert and try to answer questions from this particular research paper, or behave like a research scientist who has 25 years of experience into research into deep learning technologies and try to answer the question. And then when you're asking a question, your bot is created as if it's a 25 years old research scientist. Similarly, going forward, if you are doing a insurance related project or a medical related project, you can also give a prompt, behave as a general practitioner and answer. So that is basically that you are passing in the prompt template. Then what is return source documents true? This basically indicates whether to return the source documents along with the response. Verbose false is nothing but it is a control that it is the parameter that controls the verbosity of the chain. Okay, now this is done. What's next? Your QA is ready. Our next task is to just ask a question. Okay, let's say here I will write it down as ask a query. Okay, so let me define my chat history. Let's say chat history is an empty list. Query is equals to okay, let's say from this research paper, what is this research paper all about? What is this research paper all about? Explain in just 3 to 4 lines. And then I'm calling the result is equals to, I'll be calling this conversational chain, and then here I will pass question is my query, and chat history. Do we have a chat history? I'm not passing any chat history, so chat history is chat history If you have a chat history, you can always pass that. That is my result, and then I'll be just printing my result answer. Okay, let's see what the answer is. Great. So our rag paper is being trained, right? Now, if you just ask this question directly to POE has no idea about which research paper are we talking about. But here we have actually trained the research paper, right? So if you go back to the architecture, I'll probably take you to the bigger architecture, the complex one here, right? Wow. Okay, somehow it's still visible. So you have the documents, and then you did all this, then you're creating embeddings, and then from your vector store you are getting the relevant passage, and you are calling the OpenAI model and getting the final output. This is what is happening. So what is this output? This research paper is about a new method for multi-paragraph reading comprehension using machine learning techniques. It proposes a model called BERT that is pre-trained on a large corpus of text and can be fine-tuned for a variety of natural language processing. This paper also discusses its applications in conversational agents and question answering. Let me ask few more questions, something related to, let's say, who are the authors? Who are the authors of this paper? Okay, let's try this out. So somehow it is getting the references. It is not doing a great job. The author should be these, Patrick Lewis. Okay, it's not doing a great job, but it's okay. Let's say we'll ask something. What is the RAG sequence model? The RAG sequence model uses the same retrieved document. You can see word by word it has been copied. Uses the same retrieved document to generate complete sequence. To generate the complete sequence, it treats the retrieved document as a single latent variable, blah blah blah, and then you can see it's doing a great job. Um, what are the different experiments performed? What are the different experiments performed in this paper? Using on BART for partial decoding, fact, okay. Um, okay, fact verification, yes, it's correct. Partial decoding, partial decoding is also correct. Partial decoding is mentioned here in the Jeopardy question generation. Training setup derails, retrieval ablations, yes, to some extent it is doing a good job. Okay, last question, what are RAGs and why do we use it? RAG stands for Retrieval Augmented Generation. It is a type of model that uses a combination of text retrieval and generation. Now, let's say if I ask some random question, who is Sachin Tendulkar? So this particular, I mean, I was about to say the same thing because it does not have information about Tendulkar, right? Now, in this case, if only if your requirement is, if the question is not found in the document, try to refer to the OpenAI model. That is also possible. But we have not done that in this piece of code. In this piece of code, our main motive was only to train a model on top of a custom data set. So that's why it is not working. Similarly, last question. What is RAGs, and tell me more about use cases of RAGs. in a detailed manner. So RAGs are type of natural language processing model, blah blah blah. Some use cases of RAGs include open domain question answering, where it has shown to outperform state of the art models, and you can see it's doing a great job, right? That is it. What are the different use cases? You can simply take this piece of code and build hundreds and hundreds of use cases. One classic use case will be if you have your own documents. Let's say you have your own machine learning ebooks or EDA ebooks or statistical ebooks, any kind of ebooks. You want to train your ebooks for your own custom data chatbot to answer something from that ebook. You can use it. And if you want to use bulk PDFs, multiple PDFs, instead of using PyPDF loader, you can use a directory loader, which we will be covering in the next video. So next video we shall be talking about how to create similar kind of application for multiple PDFs, custom PDF chatbot, and going forward we will also be leveraging some different large language models for this particular task. And going forward we have bunch of use cases to talk about. Thank you all for watching this video till the end. Just a disclaimer that in this video we have neither converted our application into a Flask app nor we have used a vector database. Now people who are familiar with the generative AI space, they might know what is the difference between a vector index and a vector database. For those who don't know, let me know in the comment section and I will be coming up with a separate video talking about vector databases, the difference between index and databases, and what if I have to convert this exact project. Instead of vector index, I want to move into a vector database like Pinecone. Let me know in the comment section and I will come up with that video as well. That's it about this particular video. Just once again talking about the program. In case you want to learn fascinating topics related to data science and AI, the entire pipeline is already available. Generative AI, I have fascinating topics like prompt engineering, RAGs, vector databases, vector indexes, LHS. Lot more topics are covered in my program. It's a 140 hours of dedicated program with 30 plus projects. And in those 30 plus projects, there are 10 plus generative AI projects that are unique. You will not find those projects anywhere. That's my guarantee. In case you are willing to take this program, let me know in the comment section or reach out to me on LinkedIn, or else you can check out the link in the description and pay and be a part of the community. Thank you and see you in the next video.